All right, welcome everybody. In this room, we're going to have a talk on an update on reaching the German government via matrix, given by the wonderful networkException. Please give her a wonderful round of applause.
Hello, thank you. So yes, an update on reaching the German government via matrix. This is online, so I go by as networkException. I am from FITKO, a German government organization working in the architecture management. So, what am I updating you on? Last year, my colleague Marco and a colleague from the Federal Ministry for State Modernization and Digital Transformation and State Modernization. It's new. It was called differently last year. But so they gave a talk about this project last year at Matrix Conference. And 2 years ago, I did a talk at GPN privately, in my personal role. And I also mentioned this project briefly alongside a bunch of other projects that were going on in, the German ecosystem. And so this is an update on both, pretty much. So, I'm going to talk to you about the current state of the project, as Marco tried to, both of them were talking about last year. And I'll also come back to 2 conclusions I had last year. Things to do. First of all, Germany was missing or is missing a strategy for user matrix. We are doing all these matrix projects. I found a bunch and presented them, and we didn't have there wasn't a clear, coherent strategy for what we would do with them. And so we're going to touch on that in just a bit. And the second one is that I was looking at all of these projects. Of course, all of them are using matrix and want to do end-to-end encryption. But I was concluding that just saying it's end-to-end encrypted doesn't really cut it. So you need to follow up on that promise and deliver on it. So we're going to look today also at what this project is maybe doing differently or is trying to do to follow up to that promise. So let's first of all look at the context of our project. So in Germany, we have 16 federal member states and 1 federal government. And this is all making it very complex to work together on IT projects because this split is in the constitution. What is also in the constitution is the IT Planning Council. So the lawmakers decided to, hey, let's get together and specify and standardize IT systems together with all member states and the federal government. And their way to do this is, the Federal IT Planning Council, which is, as I said, part of the Constitution. And in that, as a board, sub-board of this council is the the Federal IT Architecture Board. So this is basically the space where the different architecture bureaus from all member states and the federal government and us, we'll come to that, meet to discuss architecture-related changes. So we are looking at, the broad ecosystem of federal government IT architecture. Together with FITKO, where I'm from, Federal IT Corporation, the sort of organizational unit that can that contributes to this board structure and does a lot of design work and supporting and facilitate these parties working together. Together we form the Federal IT Architecture Management, more a discipline where we are looking at all of these different aspects. Now, in this architecture board, there is us. So this project, working title is NEO. There's a different, long, complex term, which is the official one, but we're going to ignore it for now. And its purpose is to validate architecture principles. So, right, we're looking at matrix. How good is matrix for the things we want to do? can we use this for other projects in other architectures, so on? This is the sort of questions we want to answer. And then, we're doing this project together with the Federal Ministry for Digital Transformation and State Modernization. We come to that in a bit. And then there's also ZAPUK, the target architecture, which is a second project of the architecture board, and looking sort of at the broader landscape of communication infrastructure in Germany. And my colleague Dominik did a talk on this just 3 hours ago, so you can go watch it maybe afterwards if you haven't seen it, if it's uploaded already or later. And so that's the title of the talk. And these both projects are going in parallel, and the target architecture sort of gives the overarching frame, and we are one implementation trying to prove the target architecture as well. So we are supporting each other on different levels, basically. So what are we talking about? In Germany, if you want something from the government and you want to do it online, you have the option to go to an online service. So this is like also the legal construct, but basically it's just some website. You go to some website, fill up some forms, and then send it. And there's some infrastructure for getting it from your web browser to the correct authority that is responsible for fulfilling the request. We're not going to touch on that. Second. And the request will land in a government, a domain-specific IT system. So imagine for like a building permit, you have some complex software that's running in the authority that can handle all the intricate details of that, and they need this to work, of course. And we are assuming some kind of IT system that can take the request, and from there, you can also send back messages to the citizen. So that would typically just be, hey, we concluded your request is valid. Here's like a receipt, legally binding. We did our duty. And as I said, we're just going to look at this follow-up communication part. So this is the scope of our project functionally, where currently in the middle is Bund ID. This is a sort of, two systems in one pretty much. For those from Germany, you might know Bund ID as a sort of identity provider. So you go there, log in, and then you can use your Bund ID account for different online services, for example, or other resources online. It also has a mailbox component built in. So when you have an account, you already get automatically get a mailbox where these government authorities can send you messages. So this would be that. And this is the web interface where you can get the follow-up communication. Now, imagine Matrix. We want to add Matrix as an additional layer to this Bund ID mailbox component. So in this world, you would have what was just added, the cheeky little mobile phone. So we are adding a mobile app, and we would be using Matrix together with the Bund ID to get end-to-end encrypted messaging from the authority's IT system to you. And a more detailed look at the high-level architecture. So on the left, again, our clients that we would like to develop or modify, everything in blue, basically. We have the Matrix Client Server API, which is sort of spoken on both sides for the clients. So we also, just want to have one API the clients need to call. Then we have some Matrix server in the Bund ID that speaks the client server API. On the government side, we have also the client server API, of course. There are some SDKs already in the government ecosystem. One of them, the FITConnect SDK, which is also part of what my organization is developing. We want to expand to include the Matrix features. So ideally there, you would have a feature flag saying, okay, I want to use the new fancy Matrix communication, and then you flick that and it becomes end-to-end encrypted, and making it really easy for governments to implement this feature or for their IT IT personnel or companies working for them. This is, I think, crucial for us to succeed. And then we already still have a REST API as part of BundID that some government IT systems will use. And we want to bridge these two systems in the backend so that we can get the best of both worlds for new government services can use the matrix integration. The existing ones can still work. And in the near future, the existing REST API will also support bidirectional communications, so you can ask questions. And this is something where our bridge would, of course, need to bridge in both directions. All right. Let's look at some features. Basically, a high-level user journey, not entirely accurate, but imagine you get a push notification on your phone saying your government service request has, I don't know, an update. Then you can log in using your ID card. So you just hold it against your phone, scan it, and then the app would provide you with different features such as an overview over all your government requests, their status. You can do follow-up inquiries, so the government can ask you questions to provide documents, etc. And you also get these legally binding confirmations, receipts about your government requests back in this same app. So we would like to combine all the features and make it really nice to use. Why would we do Matrix? Sort of easy for this audience, right? But I tried to spin it in a way that makes it understandable as well. Why this is important also for us, because we can use an existing open internationally used standards, and we can rely on something established. And we don't have to reinvent the wheel. And this is the not invented here syndrome is widespread in the government. So this is something we can argue on quite a lot, and this is really helpful because it saves costs, of course, and resources that could be spent building a good user experience based on it. And other public sector organizations are also pushing for Matrix, and this is what's making it viable for us in the end as well, because that just allows us to argue, hey, this is there's some momentum here, we can use this, we can collaborate and share features. Of course, there are lots of features already here, so we don't need to implement any of these things. Basically, end-to-end encryption already exists out of the box. It's multi-device capable, easily works great. We have push notification support, and it's still, with all of this, it's still designed for customizability in mind. So we can implement our own use case without breaking the spec, and this is something that's just great. And of course, it also has established security guarantees. So we have this argument for an industry standard signal-based end-to-end encryption protocol and audited implementations. Also something that's not that far spread in the government ecosystem. So just quite a nice set of features. Now let's talk a bit about how we approach these things. And I gathered 3 things we are basically doing by day one or from day one. So from day one, focusing on usability by design, we're doing user tests and all of these things, trying to really get this point home. Going into a bit more detail about this in a bit. We also want to do we're also doing threat modeling, all the good security and privacy by design stuff that you can do from day one. And what we're also doing from day one is being really open about this and collaborating with others. So usability. As I already said, multi-device features. This is really good. We want to have an intuitive design, so just anything to get users on board with the app or with the new web interface based on Matrix. And also we want to make it really easy to use. And this is not just for citizens who don't like the paper trail gathering up at home, but also governments, of course, because I'm sure you've seen or heard of the cases where, well, you send a request online and it gets printed out in the government agency, and then they have to do everything else on paper. And this is something we don't want, right? So we want to support government authorities here as well. So simple as that. Mobile and web are first-class citizens for us. So matrix rooms, whatever rooms would map to in this image. We're not entirely there yet, but imagine rooms, and messages are just kept in sync by matrix magically. So this is, of course, a huge improvement. It, as I said, works great. But even though we are syncing and making web and mobile first-class citizens, we can still take a lot of advantage from the mobile platform features. So for once, that would be scanning and uploading documents directly using the camera. Like there's nothing easier to scan a document than just pulling up your phone these days. So we want to support that. We also want to leverage the ability to read NFC cards. So for your ID card, there's this, in Germany, it's NFC capable, so you can use physical-based strong authentication directly from within the app. We can also receive native push notifications. Web push isn't quite there yet, I think. So this is where users will feel at home with their push notifications, of course. We can log into the web using a QR code. So this is something Matrix recently implemented. It's something we want to look at because the current user experience for logging in with your ID card in Germany is quite not that user-friendly, let's say it. You need dedicated software on your machine. You need to connect via Wi-Fi. It needs to do MDNS or whatever. This is brittle. Let's use a QR code instead, and let's make it nice. And mobile devices have the advantage that they are long-lived. Browser caches don't clear. You have this expectation of a long-lived session. You can still keep it reasonably secure with your TPM and biometrics, all of that. Really nice to have, and we want to take advantage of all of this, of course. Next up, intuitive interactions. So I already touched on this. When the government has some inquiry into your to you about your government request, we ideally want to support the government to be really flexible in what they can ask. So there are different government domains, of course. They have different processes and various specific different use cases, and we want to focus on having this available. You can see some of the mock-ups in the current iteration here. And we are focusing on, of course, structured machine-readable data. This allows for meaningful automations also in the government agency. And even though there are so many things we could implement, we try to focus on prioritizing the common pain points for governments, making processes digital, but also, of course, citizens trying to interact with their government. And later down the road, we can do the last 20% of making everything hyper customizable and extensible via APIs or event types or whatever. And with this, we're doing user research as well, of course, to see how well does this work in a really end-to-end digitized process for citizens, for the government. Our next key points were focusing on security and privacy by design. So deeper look into what we do with end-to-end encryption, also touching a lot on zero trust here. And the last thing that I think is really important is reducing metadata and what we can do about that. So with end-to-end encryption, I already came to that point, but basically we have two ends in a simple scenario, right? This would be your client, your app, your web interface, and then your domain-specific IT system in a government agency. We can't really do this to a specific individual working in the government. think about people being on sick leave or on vacation. This gets complicated real fast, so we choose like the reasonable approach of having us in like the authority really of this agency in their own IT system, so it's like properly secured, as good as it gets, but then it sort of splits from there, but end-to-end directly to your phone ideally. But it isn't that easy, of course. These ends need to know each other's keys. So this is basically like, that's the whole point of my conclusion, right? We need to fix this issue. So where do we even begin with that? And let's take a page of the Zero Trust book here, maybe. My preferred way at to look at Zero Trust is doing it in a sort of practical way. So we have one Bund ID, a few thousand government agencies maybe, and up to 80 million citizens. So where do we begin with Zero Trust here? And I think the obvious thing to do is just designing against what will have a high impact when you do the assumed breach. That's basically the basis of Zero Trust. So when you assume a breach in the Bund ID infrastructure, you have this one target that you need to breach, in contrast to a few thousand or 80 million targets you need to breach. So this is what we need to concentrate on. And that leads us to centralized infrastructure. And with like not relying on the Bund ID, where do we generate trust? Because looking back at this, of course, Bund ID is in the middle. This would be the easy point to distribute keys from. But if we don't want to do that and do it like in a zero trusty way, then where do we base our trust in? So the easy fix, of course, you being matrix people, is doing device verification. But then this becomes a bit difficult. Like imagine having to go to any agency you want to talk to and first go to the desk and say, hey, I want to do like matrix verification, please, with you. Let's exchange keys so we know it's secure. This doesn't scale. It just doesn't, neither with emojis nor with QR codes. But I think we can also do better than trusting on first use, right? So another easy way out would be just say, okay, the first keys I see, I trust them. The Bund ID won't be compromised at one point, and then later down the road, compromising would be, well, accepted. And our general approach should definitely make security and key management specifically invisible for end users. Like no regular citizen wants to deal with these things, and it just work. And it shouldn't rely on them ticking some box, because they will just do that if it annoys them, and they can get further just by ticking the box. So it should just work in the background. And this is exactly what we want to do. So it's automated. There's no UI anymore. Okay, how does this work, right? We set the goal to really verify every device by default. And we have two means to do that. The first one is we can use public key infrastructure for the government side, which already exists in a sort of working way. Exact details, are still in progress, basically, or working. We're working this out, but we are assuming that we can get some certificate for governments, which we can like pin the root of in the app or the web interface, and then verify, do device verification in an automated way like that. Now this is easy because you can sign stuff. But let me tell you, signing personal data isn't great because you can't get rid of that. So what do we do for citizens? I don't know if every one of you has a certificate, even maybe for your domain, but not every citizen has a domain, so we can't really use that. What every citizen in Germany has, though, is an ID card. We already talked about this. Now, ID cards in Germany are special in the way that they don't produce signed data, really. So what it's doing mostly is like it's communicating over a mutually authenticated channel, just your name, address, or whatever is requested. This is sort of zero knowledge, but I don't know. Before zero knowledge was cool, so let's just say we can't exactly sign these things, but we want to use the great privacy features of EID. And the way we are envisioning this is by, pretty much just using your ID card, doing the transaction through the matrix chat or through the end-to-end encrypted tunnel. Basically, if the government side sees, okay, your ID card is communicating through this tunnel, we assume it's bound to that tunnel, and we can rely on that to authenticate the citizen on an end-to-end encryption level. But not much more slide here, because the nitty-gritty details are what we are currently figuring out. All right, let's continue with zero trust in quotes, but focus on more privacy aspect. Isn't what zero trust is used for usually or thought of as. But if we take the same approach to look at, well, where is the centralized infrastructure, we can also find points where metadata accumulates. So specifically really high quality metadata, such as which government agency am I talking to. This might be highly sensitive. So with one matrix server knowing all identity metadata, this isn't a great approach, and we would like to change that. So thinking of this, what can we do? Maybe every user can host their own home server, right? Then we end up in, we trust the network architecture below us, like IP, to not leak our metadata. But this isn't feasible. So I mark this as green because I think it's quite good. Let's just cut this in half, right? If we have 2 home servers and some future MFC, we could do what is sort of laid out here. So a home server for citizen would know each citizen by heart, and they would only see a pseudonymized version of the user ID of the agency. So over federation, they would speak in their pseudonymized form, and then they can't correlate which exact agency you're talking to. Likewise, on the other side, the agency home server would only know that it's talking to some citizen, but not which citizen, or specifically one of its agencies is talking to some citizen. And then we just move the problem to the authenticated end-to-end encrypted channel, where we can then exchange this highly personalized data, and we sort of end up with quite a nice solution for high-quality metadata, and calling this unlinkability, basically. Some other topics we like to look into, depending on our time budget, but we would like to look into post-quantum security, because this is also a regulatory requirement. Anything government will have the IT security people knocking on their doors. If they're doing encryption, please do it post-quantum secure. So we want to look into that. We want to increase supply chain security. So this, I put reproducible builds and binary transparency here, with especially on the web, because as I said, the distribution story for web isn't great. You end up running into scenarios where it's quite easy for web servers to just exchange the application code your browser is running. So we would like to focus on that as well, or this is something we have in mind. How do we secure an end-to-end encrypted messenger that 80 million people would use, that could be compromised by a web server faking one request, holding the web server accountable? There are technologies for this. We also want to make our architecture, our components that we're developing, auditable and modular. So this makes it easy for us to look at the security of these components, and because Rust SDK is the theme of the year or whatever, we are of course building on top of the Rust SDK and making our implementation secure and memory safe using the Rust language until we get to native code for the app, or React for the web. All right. The third pillar for our approach was openness and collaboration. So I mentioned a bunch of things that are touching on the Matrix protocol. and we really want to be MSC first here. So you haven't seen any MSC from us, that's fine. We are still sorting things out, but ideally we want to use existing MSCs for the features we're building or submit new MSCs. We don't want to split with the spec. We really want to use this community effort for our advantage, of course, and contribute back. Same goes for code and documentation and all of these good things. We do open source, I think, properly, in my opinion. We spend a lot of time on this. The legal documents for the project, the contract specifies quite extensively how we do open licensing. The contract is also public under CC BY, so you can just read it and copy the procurement terms if you like. And we do open development, so not just our code is in the open, we do a release dump, but our planning, what work packages we do, and all of that is also in the open. And the last one, less towards the Matrix community. We are doing collaboration with other public organizations. So in the federal government, with other EU member states, we are trying to find synergies, collaborate together, do these implementations together so we can save on resources and sort of support each other. What's next? We have a roadmap roughly until the mid of 2026, so next year. In that time period, we like to further prototype our app and have a testing environment set up for all of this. We want to provide an SDK and detailed documentation about the architecture. We already started on that, but it will continue over the next half a year or so, a bit longer. We would like to integrate our system into the some agencies' IT systems to just be able to demo features. So we are searching basically for public government authorities to want to test with us, and then we can show that this works well for their processes. And by mid-2026, we want to have completed an MVP that can really show all of this working together. And all of that, all the while, we're doing everything on open code. And so that's the platform. Next slide. And we are looking for public feedback on this. So that leaves me with the last slide. You can follow us. This is our repository. There's the link, QR code. Basically, everything that I just said is on there in some detail level. All the results of our work are committed there. You can also find contact details. Just browse. It's sadly mostly in German, although the architecture documentation will be in English. So I think there's already a linked thing somewhere in the README in English. So if not, I'll commit this after the talk. And you will also find the slides there. And please follow us and give feedback. All right, that's it from me.
Thank you very much. Any questions for networkException from the audience? Yep.
Hello, thank you for the talk. I wanted to know what MSCs do you plan to open as part of this project? Is there anything identified?
Yeah, so for the metadata stuff, we are looking at probably pseudonymous identities, so that would be an existing MSC. We have, of course, the whole topic of structured data, so maybe variable forms that would get you can specify some template for a form and then get some data back. This is interesting. And then we would like to propose probably some changes to the end-to-end device verification frameworks to be able to support external verification using X509. This will probably also be relevant for other organizations. EID is a bit, German government specific, so we might need to make it generic enough to support that. But these are the sort of topics we would look into.
We might also look into extending OIDC, like matrix OIDC with scopes, because we have different access levels on government authentication, and that's a huge topic. The matrix OIDC makes only rough use of OIDC scopes, and this is something to be extended in that project as well.
Yes.
That was no question.
Thanks a lot. Yep.
Thank you for the clarification. Anyone else?
You mentioned before that you were using security and privacy threat modeling in the planning phase. Could you go a bit into in which frameworks did you use, and is the result documented somewhere?
So, well, we thought a lot about this, but I think it's mostly in our heads right now. We have some early drafts and like the sort of intention where we would like to go with the project. The modeling of this will be what's next, actually probably coming up in the next few weeks. So if you have suggestions, I will probably need to leave timely to catch my train, but feel free to open a ticket.
Like on every architecture design record of the project, there's a section about security considerations, threat modeling of each individual architecture decision. So we don't have like an outline of an overall threat model, but even individually on the level of each single architecture decision. So it's a very fine-tuned threat modeling process.
Yep, but I don't know. Yeah, maybe some modeling technique or something. Any feedback, welcome.
Okay, we have a question from the Matrix room from Ollie. If you intend to have pseudo IDs anyways, could you not give or generate a random identifier per device transparently, the user doesn't see or care, and then do end-to-end encryption and transmit the user's EID using that?
I mean, the EID would already be device bound, so I'm not entirely sure. So EID is like an interactive authentication scheme, so you can't exactly like compress it into a succinct message and send it off. You really need to have like a transactive or interactive channel for this, and you also need specialized server software for it. So maybe it's a bit more complicated, but yeah, if you still have a follow-up on that, let us know in the issue tracker.
Anyone else? Yeah. Okay. Not a question. All right, if there's nothing for anyone else, I think you need to go get a train. So please, another round of applause.